Hello students, welcome back to next topic. Obviously, this is the last topic in unit number 3, pulse tube refrigeration system. We are going to discuss the pulse tube refrigeration system in detail, but very simple topic, and it will not take much time to discuss this pulse tube refrigeration system. It is also very much similar to vortex tube refrigeration system, but we are going to see a little elaborately here. So from this unit 3, these are all the topics we have seen, and we have the last topic. Now we have reached to our last topic. So we have seen all these topics. Now we are going to discuss pulse tube refrigeration system, and this is the last topic. We are concluding unit 3 in this session today, and we will start unit 4 in next session. So pulse tube refrigeration system is a phenomena of nature observed in 1961 but reported in 1964 by Gifford and Langsworth. So this is a simple but fascinating method of obtaining low temperatures. So all about the refrigeration system is to achieve low temperatures, and the problem of lubrication at low temperature is basically absent as there are no moving parts. So here also there are no moving parts like vortex tube. So here the life is also good here. So in this system, sudden expansion and release of gas are employed to get the refrigeration effect. So this is a simple aspect and simple technique also. So in this system, sudden expansion and release of gas are employed to get the refrigeration effect. So here sudden expansion and release of gas. So this is the working principle we can say. So this method of obtaining low temperatures with moderate pressure and without the use of moving parts can be used to construct compact and reliable miniaturized refrigerators. So here, this method of obtaining the low temperatures with moderate pressure and without the use of moving parts. So there are no moving parts here. That is another very good advantage and can be used to construct compact and reliable miniaturized refrigerators. So that is the another very good usage. So, if you see the pulse tube refrigerator schematic, it is a very simple diagram where you can see a compressor, and this is the pulse tube 1 and this is pulse tube 2, and when you see both, the cross sectional area is lesser in pulse tube 2. So this is the regenerator 1, that is for pulse tube 1, and regenerator 2 for pulse tube 2, and we have the interface tube, we have reservoir, and from compressor it is sent. So here we have a double inlet, and now we the refrigerant is sent to through this to pulse tube 1 and then pulse tube 2. So this is simple schematic arrangement of the pulse tube refrigeration system. So coming to its construction and working, it is very simple. The figure shows the simple circuit of phase pulse tube refrigeration system. The major components of the system are the pulse tube, we have regenerator, we have valve mechanism with a drive, vacuum system, cooling system. See, the working of the system is as follows. The compressed gas is admitted by valve mechanism to the pulse tube through a regenerator, which is which is cooled to refrigeration, that is become cold end. So that is the cold end temperature. So refrigeration temperature, and then this gas entering the tube acts as friction fictitious gas gas fictitious piston, and subsequently the gas already present inside the pulse tube gets compressed, resulting in the increase in the temperature, varying from minimum at left end to the maximum at the right end. So that is the in the figure it is shown, and therefore the heat transfer to the cooling medium reduces the temperature to some wall, that is Tr, the temperature close to the cooling medium. The supply of the high pressure gas stops after the inlet valve is closed, and therefore the gas in the pulse tube is connected to the exhaust and the help of the valve mechanism, thus releasing the gas that entered the pulse tube during pressure build-up process. So this results in expansion of the tube gas, leading to decrease in temperature at the cold end much lower than that of ambient value, which takes care of the refrigeration load. So the cycle is completed and repeated. So here it is a closed cycle type only, and now the cycle is completed and repeated. Now we see its applications. Field of application of pulse tube refrigeration system. So this system is most suitable for cryogenics, where the requirement of very low temperature cannot be met with even after employing a multi-stage or cascade vapor compression system of best COP. So here that is the biggest advantage, and this is more suitable for cryogenics, where the requirement of very low temperature can't be met with even after employing a multi-stage cascade vapor refrigeration system. So here it is such a very important type of system. The pulse tube refrigeration is suitable choice for very low temperature if the cooling temperatures are limited to a few watts. So Gifford and Langsworth reported the following cold end temperatures with the cooling medium temperature of 300 K and helium as working gas at the pressure of 25 bar absolute. For a single stage pulse tube, it is 124 Kelvin, and for two stage pulse tube, it is 79 Kelvin. And Professor Parulekar, so he is from IIT Mumbai, reported the lowest temperature of 214.5 degree Kelvin with a single stage pulse tube without heater load at the cold end, using air as the working medium. So this is the another research view came into picture. He is the professor, and Parulekar is from IIT Bombay, and he has concluded this. And he reported that the lowest temperature of 214.5 Kelvin with a single stage pulse tube without heater load at the cold end, using air as the working medium. So this is the a find from IIT professor Parlekar, and this is the topic about pulse tube refrigerator system. And students, now we are completing unit number 3. In the next session we are going to meet and discuss the fourth unit content, and that is fourth unit is little simpler than unit number 3, and we will start that in next session. Students, we stop here, and as far as the references are concerned, these are the reference books. You can refer R.K. Rajput. So R.K. Rajput is a, good book for this particular topic, and no need to refer Kurmi or any other book for this particular topic. And references, these are the references. And even Kurmi is not giving much information on pulse tube refrigeration system, so better you can rely on R.K. Rajput for these type of unconventional refrigeration systems. So we stop here, students, and these are the e-resources. You can refer these e-resources also. we can stop here. We will meet again in next session, where we are going to start unit number 4. Thank you, students. Thank you. We will meet again in next session where we are going to start the unit number 4. Thank you, students. We stop here.